Dyna-Living 400W wind turbine promises reliable off-grid power from a gentle breeze. Either we've reached backyard energy independence or we're buying a spinning lawn ornament. On paper, it's a 400-watt, 1224V auto-charging turbine with low 2.5 ms startup, nylon fiber blades, and a smart brake controller that's supposedly quiet and efficient. Sounds slick, right? But here's the thing, wind math is brutal, small rotors have limits, and cheap controllers can kneecap performance. Here's what caught my attention and why I put it on a proper mast and wired it to a battery bank. I actually installed and tested it over 30 days through calm days and a couple of stormy gusts. I've put the direct link to check current pricing in the description, but before you click anything, let me show you what I discovered after 30 days of testing. So what does the Dyna-Living 400W actually claim to do? It's marketed to charge 12V or 24V battery banks automatically, spin up at low wind speeds, and deliver up to 400 watts under strong wind with quiet, low-vibration operation. The headline promises boil down to 400W rated output with peaks in high wind cut-in around 2.5 ms for earlier charging, smart charge controller with overspeed protection and braking, easy install, and durable blades. Sounds criminally generous, right? But here's where things get interesting. The physics of wind power, your mounting height, and the included controller determine everything. Reality check. Claim 400W output. Reality. You'll only sniff 400W in sustained winds around 12-13 ms, 27-29 mph with a clean airflow and a good controller. Here's why. Power from wind scales with the cube of wind speed and the swept area of the rotor. This turbine's rotor is roughly around the 1.2–1.4 meter diameter class, so even with an optimistic efficiency, at a common backyard wind of 5–6 ms, the theoretical max is well under 150W. My logs in 4–8 ms winds showed typical charging between 15–120W with brief gust peaks near 180W. In one stormy hour with 10–12 ms gusts, I saw short spikes higher but not sustained. Translation: 400W is the rating, not the reality for most sites. Claim: low 2.5 ms startup. Reality: the blades will indeed spin in a light breeze, but charging your batteries is another story. I didn't see meaningful current until about 4.5 ms, and usable charge rates didn't show up until about 5.56 ms. That's normal for small turbines, but the marketing glosses over it. Claim: quiet operation. Reality: below 6 ms it's pretty tame. Above 8 ms expect a noticeable whir and some blade hiss. At 10 meters away I measured mid-50s dB on a breezy day, which is fine outdoors but not rooftop bedroom friendly. And if you mount it low or on a flimsy pole, vibration travels. That's not switching, that's expensive confusion. Claim: smart controller. Reality: the included controller works, but it's a basic PWM-style unit in most kits, not a true MPPT wind controller with a robust diversion load. That matters. A PWM controller tends to clamp voltage and leave power on the table, particularly in gusts. Under extended high wind, my controller rose to the low 60s Celsius enclosed. It didn't fail, but I wouldn't trust it as my only protection in a gale. Several user reports around similar 400W kits mention overheated controllers and missing or undersized dump loads. A proper diversion controller with a resistor bank is the adult move. Claim: easy install. Reality: kind of. Assembly took me about 90 minutes. The manual is short on specifics, the phase wires weren't labeled clearly, and you'll want thread locker and a torque pattern on the blade bolts to avoid wobble. The real work is the mast. Get it 10 feet above anything within 100 feet, guy it properly, and run thick cable to minimize voltage drop. Here's where it gets mathematically impossible. Expecting 30–50 kWh per month from a small horizontal turbine in a 4–5 ms average wind site. In my tests, a breezy week yielded about 1.9 kWh total. In a stormy week, just under 4.2 kWh. The plot twist: if your average wind is 7–8 ms and you mount it right, it becomes a legitimate trickle companion to solar, especially at night. Build quality: the casting and hub feel decent for the price, the blades are stiff nylon fiber, and the tail tracks wind reliably. Hardware is generic, add your own stainless fasteners where it matters. Bearings spun smoothly after a month. No obvious play or rubbing. Power output and efficiency. Expect 1560W most of the time in 46ms, 80-150W and 68ms, and brief spikes higher in gusts. If you need predictable energy, solar will do more per dollar in most regions. This unit shines only where wind is consistently strong or at night to complement solar, controller, and safety. The included controller is the bottleneck. It does protect against overcharge and offers a brake, but it's not an optimized MPPT wind charger, and the diversion load is minimal or external only depending on the kit. Here's what nobody tells you: without a proper dump load, if your batteries are full in high wind, the turbine needs somewhere to put that energy or you risk overspeed. Noise and vibration. On a rigid guide mast it's fine. On a roof, hard pass, sound ramps up with wind speed. Low-frequency vibration transmits into structures. User review patterns. Sift through reviews across sellers of this same rebranded design and you'll see a pattern. Fans love it on boats or off-grid sheds in windy sites. Critics report mediocre output in suburban backyards and occasional controller failures. Red flags. Identical photos across multiple brands and ambitious monthly kWh claims are your clue. This is a generic platform. That's not automatically bad, just know what you're buying. Verdict: buy with caution. If you have an open, windy site averaging 6ms or better, a proper tower, and you're pairing it with a real diversion controller and battery bank, the Dyna-Living 400W can add useful watt-hours, especially at night or during winter when solar dips. At its usual price around the low to mid-200s, it's decent value as a supplemental charger. But if your wind is mediocre or you plan to slap it on a short pole behind a house, save your money for more solar or a higher-end turbine like a Primus Air 40 if wind is truly your resource. Worth it if you respect the physics, mount it right, and upgrade the controller. Otherwise, it's tech roulette. Stay savvy out there. Thanks for watching. If this review saved you from wasting money or helped you find something actually worth buying, I've put the link to check current pricing and read more reviews in the description. And hey, if you do decide to buy through my link, it helps fund these investigations without costing you extra. Got wind speeds over 6ms where you live? Drop your average wind and setup in the comments and I'll help you sanity check the numbers. Next up, I'm testing a hybrid solar wind controller that might unlock more from small turbines. This is your off-grid gear watchdog signing off.